by my standards, so early. I was in the audience. I thought the sound was not very good. And let me tell you, it's worse up here. So what I want to do is to talk about a subject that I actually haven't seen in the creativity literature much, if at all. Whoops. What's going on here? This is part of a larger project. Work was done by the first author, who unsurprisingly is a PhD student in mechanical engineering. There's myself, who tends to sit and pontificate. We have a psychologist, Alessandro, and another mechanical engineer, Marco. The question we asked is this: given that chronobiology is the study of the role of time in all our activities, and we're familiar with this, most people know about the diurnal 24-hour rhythm, but there's shorter rhythms. Eye blinks, for example, have a rhythmic behavior. There's longer ones. The really long ones are things like agriculture, hibernation. So, and studies of chronobiology show that this affects people's behavior fairly dramatically. So, boy, something's happening with this device. So, the obvious question is, I'm interested in design. Does this apply in design, which is a subset of the population, in the same way as it does to the population generally? And we, having made all those rude comments about divergent thinking tests, we used one of those. But we had another question, one that we don't see elsewhere, which is that, is there a difference, not just naturally, but due to education? And the reason why we ask this question is that we see this all the time in our field. The effect of education background changes things that we think maybe shouldn't be changed, that people are the same, roughly, statistically. And let me just very quickly show you this. On the vertical axis is something that measures the cognitive focus in a design activity on the problem and the solution. And we divide the amount of cognitive focus on the problem by the cognitive focus on the solution, and we get an index, a nice dimensionless index. Dear, oh dear. Here's the result of 3 sets of teams doing the same task: mechanical engineers, industrial designers, and mixed teams. And the task they're given is one that everyone knows a lot about. And we can see that there are these statistically significant differences with a reasonable effect size. When we give them a task that no one has come across before, we see fundamentally different responses. So the claim that we can just put everyone together hides this. So we were interested in pursuing this when we were studying chronobiology. We did the standard alternative uses task. We had 40 students just to make life interesting. I sit in the US, those guys I showed sit in Italy. We did this work in Sweden. But Europe is about sharing. And we did all the standard things you do. So here's the results. We used EEG, and it really doesn't matter, but that's the way we're doing the measurement. And we just took these 40 students, and some of them are in the morning, some of them in the afternoon, and look what we get. Now, I could stop here because this is actually the result, right? it's a very interesting result, which you can see that it's not just there's small differences. There's actually some, not just quantitative, but some qualitative differences here, which need explanation, which I'm not going to give you. Right? But as we go into this, this is on the left, industrial designers, and on the right, engineering designers, mechanical engineers. And there's something fundamentally different between these two groups. And this is something we've, as we tease this out, we're seeing across a lot of activity, that bringing everyone together in order to get rid of individual differences now actually starts to mask something fundamental. And, you know, I can show you, and I will show you, these graphs as we dig deeper into this, but it's really just telling you the same thing. So these are the different bands. And as I said, you know, you can look at these more carefully, but that's not the interesting part. So what I want to finish with is, what is this telling us? Well, it's telling us the thing we expected, right? The time of day influences what we call design neurocognition. This thing runs by itself. Is someone pressing the button elsewhere? It affects different brain regions differentially. And we could have talked about that. But the really interesting one, I kid you not, I am not doing anything. It's going to finish before I do, is that the educational backgrounds play a dominant role. Now, this is interesting because if you're in the education business, this is great news, that you're actually making a change, and quite a profound change. So maybe does this have an automatic progression?
I think maybe maybe someone inserted a slide.
I mean, I don't mind someone interfering with what's going on. I just like to know how it's done. Anyway, so maybe time of day becomes a confounding variable that we've just not considered in our analyses before. That based on this small study, you wouldn't make this claim, but if this study turned out to be general, maybe it affects design practice, maybe even education pedagogy. And this fundamental thing for me out of this study is that education, it's clearly not running out of time, education really is a missing component in pretty much most of our studies. And then, of course, there's lots of things you could imagine doing from here. More complex tasks, the alternative uses task has something going for it. The big missing element in a study like this is that people fall into categories called chronotypes. There are morning people, evening people, and there are people who are good all across the entire day, and there's also people who are no good across the entire day. Maybe other metrics, looking at activations in regions, is a pretty simplistic approach. There's a very nice book about critiquing this called Beyond Phrenology in Neurocognition. And if you remember, phrenology is the 19th century idea that you could tell a lot about a person by looking at the shape of their skull. The classic one is, if your eyes are really close together, you have criminal tendencies. And if you've got a high forehead, you're intellectual. Actually, that might be true. But there's other measures. We should be richer in our conception. And of course, actually look at creativity itself, not this proxy for creativity, but the creativity of the outcomes. And now I want it to go, and let me stop there.
About how these effects emerge. So I'm assuming that these are undergraduate students who likely had similar education before entering these programs, and then maybe diverging through training. And so I wanted to see if you have any data that sort of suggests that there may have been trait level differences that exist before that versus that they were trained into these types of thinking through their undergraduate programs. And in that case, it sort of suggests something really interesting about how we can encourage people to develop skills that look more like the industrial designers, or vice versa if there's a use case. So I just wondering if you could talk about the temporality of what was learned that led to these.
I can speculate, but I can do more than that. Lila Krisaku and I have a project funded by that nice gentleman up the back, which is actually going to tease out, or its goal is to tease out, is there self-selection? People who have different characteristics end up here, or is there education, or what is the mix? I can tell you the education of engineers and industrial designers is fundamentally different. Engineers, for a good reason, have to end up in a very specific place, which has to do with safety and risk. As a friend of mine who's a heart surgeon said, you want me to be creative? You want me to change something that I know works? The industrial designers work with things that have low risk. I think that has a big effect on the progression of their education.
No, it's the monitor. Okay, this will do it. Okay.
Everyone, my name is Emma, and today we're going to talk about the effects of multiple intervention neurofeedback on novel idea production and neurocognition. This work is a collaboration between Trip Sheely at Virginia Tech and John Garrow at UNC Charlotte, and is supported by grants from the National Science Foundation. So neurofeedback creates an opportunity for there to be a feedback loop in the head for self-assessment of what's going on while you're designing. What's interesting about this type of feedback is that individuals, as they're working through it, don't have an understanding of really what the colors that we're showing them on this heat map actually mean, but it's giving them some sort of sense of performance, because we're telling them initially up front that this red correlates with a higher cognitive load or higher cognitive capacity, and we're asking them to try to produce as much red as possible while they're going through the design prompts. So in this particular study, we had 30 graduate civil engineering students work through 5 individual design sessions. In the first session, there was no feedback administered. In that session, we were just kind of measuring a baseline, because we didn't have a control for this experiment. And then we had 3 sessions in the middle where feedback was administered. And then in the final session, we just measured retention. Throughout each of these sessions, they worked through 5 design prompts. The first were civil engineering related design prompts, and the final task was the alternative use task. Throughout this, we were measuring them using the OB Lab FNIRS headband. And then we were also just recording all of their responses on a microphone to compute the number of ideas that they produced. And each participant was told that they were allowed to have as much time as they wanted to sit with the task. If they were ready to move on, and we progressed to the next prompt, or we concluded the session. So the different evaluation metrics that we looked at were the change in blood oxygenation in the prefrontal cortex, also the time spent on task, and the number of ideas produced. Here we looked at the time spent on task as a corollary for the decrease in cognitive decay, just because it creates the opportunity for more ideas to occur in an ideation session. And then obviously like idea fluency and change in blood oxygenation. So this is the average of all of the oxyhemoglobin across all participants and all of the channels that we wanted to look at. As you can see, when we introduced the feedback, we see this like big jump in session 2 that does not persist in sessions 3 and 4, and then it increases again when session 5 takes place, and we have the novelty of no longer having there be feedback present. And so for the ease of clarity, we went on to separate our individual assessments into like activation and deactivation. So if we have all of our blood oxygenation, then we separated our positive and negative integrals. There were 2 regions that stood out in the analysis. Those were the right ventrolateral prefrontal cortex and the right orbitofrontal cortex. And then we wanted to look at 3 different relationships. The first was the difference between session 1 and session 2, the introduction of feedback, session 1 and session 4, the final feedback session, and session 1 and session 5, 5 being when the feedback was removed, looking at the total effect of the feedback. In the right VLPFC, what we saw was that there was a significant decrease at the introduction of the neurofeedback, and then also once the feedback was removed, there was another significant decrease, both to a moderate effect size. The same thing happened in the right OFC, but in this case, we had a significant ANOVA test across all of the different comparisons, and then also the 3 relationships that we were particularly interested in exploring had a significant decrease to a large effect size. So the reason that we were interested in looking at this deactivation and activation separately was because we were interested down the line, as these are just preliminary findings, understanding what the role that this played in a broader inhibitory process. We're not saying that this directly relates to inhibition, but it might be something that's playing the role just because typically we see activation as being associated with an increase in cognitive capacity, an increase in performance. So in order to understand what's going on, we wanted to separate the activation from the deactivation so that we weren't necessarily like losing any data by averaging those 2. Now, looking at the 2 performance metrics that are not related to blood flow, we wanted to explore the mean time spent ideating. Here we saw a significant increase in time spent ideating when comparing session 1 with the final feedback session and with the retention session, which did decrease after the feedback was removed, but was still significantly higher than our initial session. Similarly, looking at idea fluency data, we did see a decrease from the peak that was seen in the second feedback session, session 3, but overall, after the introduction of feedback, all of our sessions saw significantly higher idea production. And in sessions 4 and 5, we saw a pretty significant effect size. So from here, what we're interested in is, or the reason why I'm presenting this today is to get a better understanding of where to go next. Obviously, there is an explanation for like, oh, well, we're seeing this increase in performance because people are practicing these tasks. But what we did see, particularly like in the neurocognitive data, looking at like the oxyhemoglobin data, there is that decrease in the effect size between sessions 4 and 5. We see that in the ventrolateral prefrontal cortex and the orbital frontal cortex. And then also in our 2 performance metrics, we're also seeing a decrease in the effect size between sessions 4 and 5. So it seems like there's an improvement in performance that takes place during neurofeedback that drops off. And so in order to understand whether that is completely related to the feedback or completely assess efficacy, it would be beneficial to perhaps repeat this with a control and with a placebo. Or another thing that we could do is just extend the timeline, perhaps do more feedback sessions, or increase the amount of time that takes place between the sessions, or increase the amount of time that takes place between the final session and the retention session, but just get a better understanding of how this tool is best used. Another thing that's worth noting is NIRS the best tool for neurofeedback? We know that NIRS is a great tool as a measurement device, but is it necessarily the most effective tool when there is a bit of a barrier? It's not the most accessible device, and maybe there's other interventions like meditation or like walking or like framing. There's all of these tools that we all use for benefiting our own creativity that might be more efficacious than using FNIRS for neurofeedback. So comparing those different interventions is something that is worth exploring as well. So if you have any opinion on this and are willing to contribute it, please reach out to me. There's my email right there. It's easy to remember. It's just Wemma. And thank you for your time.
Great talk. I love the neurofeedback stuff because getting at a metacognition and then I feel like making people aware of how they're thinking, which is really cool. I wondered if you had any sense of when people might return to baseline. If I have any idea of where that might go or how long that feedback might just not exist anymore in terms of brain activity. And secondly, do you have any data when people through or who you could go through in 5 sessions, all controls without any feedback, and see how those comparisons? That would be an interesting take.
What do you mean by baseline?
Where they started in session 1, like for having any neurofeedback.
I think that's what we're interested in assessing, with perhaps repeating this with a control, or just extending this timeline and seeing, like, continuing to do measurement sessions without feedback administered and watching how their performance changes, and also seeing if there's a particular trend that takes place throughout the session in terms of uptick in blood oxygenation in those 2 subregions in particular, and if that naturally reoccurs when they're going through ideation, even when feedback's removed. So yeah, watching that trend would be interesting. Maybe it doesn't happen at all, but it's something that is going to require more time and more participants.
Great work, thank you.
Thank you for your question.
Morning. All right, so over the next few minutes, I'd like to share with you all a method to potentially enhance the creative and divergent processes that design students experience and undergo while they're designing products. So how are we doing this? So our experimental study looked at implementing a survival context, so essentially placing design students in this survival mode of thinking. So what does that involve? I want you to imagine that you are stranded in the grasslands of a foreign land and you don't have any materials. You don't have access to food, you don't have access to water, and you may potentially need to protect yourself from predators. So we were curious to see how designing a product in that context might make you more creative, less creative, that sort of thing. As you might imagine, in a context like this, otherwise ordinary objects, so for example, maybe something like string, might now become very creative. You might need to use them in unusual ways. So for example, if you have access to something like a string, now in a survival setting, maybe you can use that to hang items to dry, might use it to fish, to stitch something up if you need to, that sort of thing. So we were curious in this because we thought that this survival scenario might actually encourage designers to design for the extreme user. So this product might only be useful in a survival setting, but we thought that it might generalize and be more readily original and creative to people at large. All right, so these are the design briefs that 3 separate groups of participants saw. So design students were either in a survival with predators conditions. You can see the brief on screen that they read. And the key difference here between the brief on the left and the right is that the one on the left contains the words "from predators." We were also just interested to see if the level of threat might influence creative processes, creativity of designs. So the brief on the right is exactly identical. It just doesn't contain those 2 words "from predators." And then on the bottom, you can see the moving brief. So this contains very similar elements as the other briefs. They're still moving to a new place. They still have to transport belongings, but there's no element of needing to survive, essentially. And for all 3 of these groups, they were designing a camping bag. So they were designing the same product, and they all had the same amount of time, 20 minutes. Great. So just looking at a couple of examples of some of the designs that these students came up with. You can see on the left-hand side of the screen, survival with predators. A few qualitative observations from our raters. We did have 3 independent raters who took a look at all designs and rated them for usability and also originality. Those are then combined for an overall score of creativity. But before I get to the quantitative results, just want to note a few things, point out some stuff. So in this left-hand group, many of the raters noticed that a lot of these designs tended to be convertible or multiple use. So they had elements that for example, you see here there's a walking stick, so you could use that potentially when you're traversing the grasslands, but it might also be useful as a weapon, so potentially fending off those predators. In the middle group, many of these designs tended to focus on just transporting belongings, but there were some unique elements. So for example, things that might help with navigation. Some of the bags contained like a compass element. And then on the right-hand side, we have those individuals who were in that moving control group. So the designers noticed that many of these designs had typical elements that you might expect when you're moving or planning to move. A lot of these designs look like luggage. They have wheels, the typical handle that you might see. All right, very briefly, some of our quantitative results. So these are on the overall creativity scores that I mentioned before. We conducted an analysis of covariance. So we used an AUT score that all design students took before the experimental phase of the study, just to serve as a baseline of their creativity coming in. What we can see is that there was a significant difference such that those in the survival with predators group overall had more creative designs than those specifically without predators. So not a difference between the moving control group. But we're excited by these data. We're still in the process of collecting data. We're thinking that this might be a useful exercise for design students to think a little bit more divergently, and potentially also for established designers. Maybe it's a way of kind of reducing functional fixedness, getting out of a rut while they're designing a product that maybe they're thinking of in a very typical way. All right, thank you very much.
Our next speaker is
Oh, it is. Okay, great. Yeah. Thank you.
good morning.
So thank you for letting me the opportunity to present this work that we have done with some sustainability research laboratory and that we do in France. So I will present to you some preliminary results. It is important to have in mind that in 2022, 38% of the 235 million tons in our food supply go unsold or uneaten in the US, and that American householder waste around 48% of their food. So even if we have in mind, if we don't have in mind these exact numbers, then we know about the challenge of food wasting, and we know that it impacts a lot of all the sustainability measures. Most of the time, we just think, why don't consumers behave in a pro-environmental way, knowing that we try to save our planet, something for everybody, right? So previous papers have shown that it is mostly related to the use of bad coping strategies, such as individual perception of powerless or their incertitude or skepticism about climate change. But we also thought maybe the literature of creativity has something to say about that. And we know that some exploration of solutions when we face a problem might be biased, especially by cognitive fixation effects. So if we didn't have any cognitive bias, well, we should be able to explore each solutions as much as the other one. And actually, what we can see in some of the latest studies is that we have fixation effect that lead us to explore only a little part of the possible solutions, and we forget to explore many of the rest of solutions. So this fixation effect exists in many different tasks. It exists in the general population. It exists also for design experts, and it develops with age as the knowledge that we have develops. So what we wanted to do is to study whether this fixation effect exists in a sustainable divergent thinking problem, especially on food wasting, and we needed to create a tool for doing it and measuring it. So we asked 155 adults to generate as much original solutions as they could to make sure to eat without food wasting during 5 minutes. That was one of many other tests that we had in the laboratory. And so we created a tool using the CK theory, which is a design theory that helped to create the map of all the solutions possible when facing a problem. And what is very interesting in this theory is that it would mirror the ideas that we can generate and the knowledge that we should use for generating these ideas, so we can predict pretty well the fixation effect that we might see. So I'm sorry, it's a little written, but we end up with 4 different big paths of solutions. The first one is that we can do something by acting on the organization of the production and delivery chain. The other one is that we can act on consumers' behavior, acting via the collective system. And finally, we can also do as if we stop wasting, even if it's not true, and just look somewhere else. And in between the 24 big categories that we had, we compared how much these categories were significantly more used than the theoretical expectations. And so what we found in adults is that 5 of these 24 categories were very, very used. The first one was modifying the purchase process of consumers, so buying in details, playing with the amount of food available. You can reduce what you have in your plate, but you can also just choose part before for eating more. Favor food according to their qualities, so ugly carrots can always be eaten. Distribute to allow other to eat, also transform the food. And we wanted to investigate whether this fixation effect develops. So we want to see children, early adolescents, and middle adolescents for doing it, and we asked the same questions. And what we found is that, well, early adolescents and middle adolescents had the exact same fixation effect as the adult. And for children, they just didn't think so much to the transformation of the product and also the purchase process, because maybe they didn't have enough knowledge on that. So to conclude, because I'm a little bit late, To conclude, I just wanted to say that this is a new way to look at sustainability problem by investigating how we are fixed and biased during the generation of our solution. And that what we can see is that compared to other tasks where we look at the fixation effect, actually people didn't really explore so much of the solutions, and that we can have impacts, of course, in design workshop in classrooms, and this is what we're doing right now. So thank you for listening.
Any time for questions for no, not this time, but you can go ahead and find your after the session or any breaks. So our next speaker is Dr. Cassie.
Oh, okay, so today I want to talk to you about collaborative creativity, and especially in advertisement design. Sorry, I'm small. So the thing that I'm really interested in studying is how do groups create together? And specifically, what is the role of a leader in these groups? Do groups tend to use one single idea, or do they tend to use many ideas and try to combine them? And is the leader the same for these big picture conceptual ideas that are involved in creating an advertisement, or are they a different leader when we're talking about small details? And the other question that we wanted to look is, how do groups respond to negative feedback? We know that negative feedback is an incredibly important part of our lives, whether we like it or not, but everyone encounters it, and we want to know how negative feedback can affect this group and specifically leader structure. So to do this, we had groups of 4 students, although sometimes only 3 showed up, sketch an advertisement for an ice cream store for 15 minutes. I'm going to show you 8 groups that we've analyzed today, but we're hoping to get 20. So after they sketch these advertisements themselves, then they come together and they have 15 minutes to create a rough draft of an advertisement. And then we give them negative feedback where we basically tell them, be more novel, be more creative. And then they have 20 minutes to adapt their design using our feedback. So this is really preliminary and exploratory data. So I want to show you examples of the kinds of things that people are creating. And we've categorized them into these 3 groups of go back, go forward, and resist. And it'll make more sense when we get into them. The go back group, here you can see there are 4 great sketches of ice cream designs, and they're all very different from each other. Now, for their first draft, they've come up with a design that's completely different from any of the 4 drafts that they individually made themselves. After we give them negative feedback, then they go back to one of their original drawings. For the go forward, now we see the opposite. We again have 4 very different drawings. However, for their first draft, now they've really recreated one of their original drafts. However, again, after negative feedback, now they've come up with something entirely novel that is not similar to any of their original drawings. For me, my favorite so far has been the resist group. Again, you can see 3 very different drawings. When they get the first draft, it looks very similar to one of their original drawings, the cube. And then after negative feedback, again, it looks identical to their original drawings. So here I want to show you the preliminary results where we're looking at the leader's dominance. This is their conceptual dominance. So when we look at the poster, how much of the actual design is based on one person's idea. And 1.5 means 100% of the ideas came from one person, and it can go into the negatives, but this is just the leader. What we see is that from the first draft to the second draft after negative feedback, there's a trend towards egalitarianism. Usually the leader is much more dominant in the first draft. What we do see is that there were changes in leadership. So even though the leader is losing their dominance from the first draft to the second draft, it's still the same leader who's contributing. We only saw 1 increase in dominance from first draft to second draft, and we saw 1 where they stayed the same. And I think that you can guess which one had the same dominance at 1.5 from the first sketch to the second. At the details, so the small picture, we saw a different story where in general it was much more equal between the two drafts. And we only saw 1 leader change, and in general the dominance stayed the same from the first draft to the second draft. So this again is really preliminary. We need to finish analyzing. Currently we've collected 18 groups, but we're hoping for 20. It's a very intense analysis where we're recording the conversation and trying to look and see where these ideas have come from. And then we also want to be able to look at, is it optimal to pivot leaders or to stay the same? And we'll have expert raters rate the novelty and quality.
The 401 highway. It's not actually true, but some of you may have experienced the congestion on the 401 highway trying to get to the conference from the airport. And in fact, Toyota is the worst city in America for traffic in 2024. And I would argue that this problem is exacerbated by the way that we've approached engineering design over the last 50 years, which has been a reductionist approach where we isolate individual elements of a system and then try to optimize them. Instead, seeing the problem as part of a system opens up new creative solutions. And luckily, Toronto has figured this out. They've recently pledged $7.5 billion investment in trams over the next decade to address some of this congestion. This idea of systems thinking, expanding the problem, and looking at it in different ways is not intuitive. It takes more cognitive resources. And so what we were trying to do is look for ways to make this cognitively easier to do, offload some of that cognition. One approach for that is through concept mapping. Concept mapping is a tool to help offload cognition by externalizing relationships and paths of various items, concepts, problems connected to the original problem. And so what we asked was, what's the effect of concept mapping on students' neurocognition when designing? And so we asked 66 civil engineering students that think about traffic and mobility. We gave them a task. Their task was that mobility on campus needs to be redesigned, and your role is to develop a document, a problem statement, containing everything you could think of to be improved. Half of these students, before we gave them this task, we asked them to develop a concept related to everything they could think of connected to mobility, and the other half we did not. And what we measured was the change in oxygenated hemoglobin in their prefrontal cortex while they're doing this as a proxy for changes in neurocognition. We also measured their semantic similarity between words and their problem statements as a proxy for the exploration of the design problem statement. And then we also measured the number of words included in the problem statements as a proxy for cognitive effort. And what we found was when you ask students to externalize all of these ideas related to mobility and show the relationships between them prior to developing the design problem statements, it led to a significant reduction in activation of the left prefrontal cortex. In other words, the use of the concept mapping tool led to a cognitive offloading. We saw a reduction in cognitive effort of oxygenated hemoglobin, specifically in the left prefrontal cortex. And this aligns with some of the previous research that suggests that these hierarchical structures of concept maps facilitates the navigation through system components and reduces overall self-reported cognitive loads. It didn't just change neurocognition during design problem statements, but the intervention led to a more semantically diverse word choices within their problem statements. So students who use the concept mapping tool had significantly higher levels of semantically unique words. And it led to longer problem statements. So to summarize these findings, the externalization of concept and the relationships prior to design led to a better outcome with less cognitive effort. And the takeaway here is this is just one way to externalize all the different types of ideas and concepts that are related to problems and think about it in new ways. There's many other types of ways you can think about externalizing this information through sketching, working with an AI agent. And so this research really opens up the opportunity for more exploration about how externalization of ideas helps offload cognition, and then the effect of that on design and design creativity.
Don't have a fifth grade, I'm sorry. Okay, we're gonna set up for our keynote of today.